This is assignment 7-2. The lesson was on derivatives and integration of exponentials. So let's look at number 1. It says sketch the graph y equals e to the negative x. So that's what we're going to do first. I'm actually going to do 1 and 2a, and then I'll go back to 1 and b. So for number 1, could you sketch this if you need to? So a point on this graph would be 0, and e to the 0 is 1. The other one, actually, we're going to use negative 1. And if I go negative times a negative, that answer is positive e, which is about 2.7. And there's an asymptote at y equals 0. So if I graph this, I'm going to start at 0, 1, negative 1. Again, e is about 2.7. So find where like 2.7 is. And then what's the curve here? There's an asymptote, remember, at 0. So there's a nice curve. All right, what am I going to use? What do I use? Yeah. One of these I should be able to use. All right, draw a tangent line at 0, 1. So see where 0, 1 is. A tangent line means you take out your ruler and you draw it in such a way where it only touches the graph at 0, 1. Oh, that one's kind of off. I was trying to look at it a little better. Let me see if I can do a better job. That's a better job. Okay, so that line there touches the point only at 0, 1. That's called a tangent line when it touches at one point. And then right away, let's just do 2a right away, which is what's the equation of that tangent line? So we already know that x is 0 and y is 1. That's the point that it's touching. To find the slope, we need to do the derivative. So the derivative of e to the negative x is e to the negative x. And then the hook on comes from the exponent. So the derivative of negative x is negative 1. So if I put it together, that's what it looks like. And then the slope, if you plug in 0 for x, you get the slope to be negative 1. What? Yes. E to the 0 is 1. So it's negative 1. Correct. So the equation of the line then would be negative 1 x subtract 0 plus 1, or another way we could just write that is negative x plus 1. Let's do the second part. I'm going to redraw the graph. So for the second one, I'm going to redraw that graph again. So again, I'm going to have 0, 1, negative 1, and 2.7. And I'll draw this curve. And then this time we're using this point right here. So use the point negative 1e. Draw a tangent line. So right away you should notice this tangent line is steeper. Like it's a bigger negative number, right, than the other one. So it's steeper. We should notice. So instead of negative 1, it's going to be a smaller, if we like, a more negative number for a slope. So in this situation, x is equal to negative 1, and the y coordinate is e. And then we already found the slope of the derivative formula here. So remember that y prime is equal to negative e to the negative x. So that hasn't changed. So to find the slope, we take the derivative and plug in negative 1. Well, if I plug in negative 1, the negative times the negative makes it positive. So it's negative e to the positive 1, or just negative e. And then math, that's a number. So if I put this together, it would be negative e, and it would be x plus 1 plus e. And that would be the equation of the line. Done. So that's like 1a, that's 2a and 2b. Can't even write it. There it is. So we just did question number 1, 2a, and question number 1, 2b. So there's the first two questions done in that order. The next question is just do a bunch of differentiating. So we're learning some new derivative rules for exponentials. They're really simple rules, which is nice. So if I want to take the derivative of that, e is the best rule of all. You just write itself. So what's the derivative of e to the 5x plus 1? You write down e to the 5x plus 1, and then the exponent has the hook on that you multiply after it. So the derivative of 5x plus 1 is 5, and that's it. I'm just going to talk you through it. Are you willing to press pause and try the derivative following the rules for number 4? So this base is not e, not quite as simple, but that just means there's an extra ln hook on at the end. So if the base is not e, it needs a hook on of ln and whatever the base is. That's it. Otherwise, it's the same. So I write down what I see. So what's the derivative of 2 to the negative 5y? You write down 2 to the negative 5y. The hook on, the derivative of the exponent, is negative 5, and then it needs an extra hook on of ln 2 because the base is not e. So this is what it looks like. So if the base is e, it's perfect, right? It doesn't have that extra hook on. But if the base is anything other than e, it needs ln and whatever that base is, and then it's done. Number 5. Oops, we're not doing Zoom, right? I just pressed the wrong one. There it is. Number 5, what's the base? So that's the first thing I noticed. So write down the question. So I noticed the base is 5. So the derivative then is, copy it down. So 5 to the t squared subtract 2t. There are 2 hook-ons. So the derivative of the exponent is 2t subtract 2. And then the next hook on is ln and whatever the base is. The best way to learn is to try it first and then press play, but you already know that. Number 6. I'm going to write it calculus friendly right away. So if I see square root of x, I go x to the 1/2. Subtract 2, so I do that immediately. And then what's the derivative? So what do I notice? The base is e. So first of all, copy it down again. E to the x to the 1/2, subtract 2, times the hook on is the derivative of the exponent. So that's 1/2 x to the negative 1/2, and the derivative of negative 2 is 0. And because the base is e, it only has the one hook on, and it's done. So again, understand how to take the derivative of the exponent, that's the hook on, and that's it. Number 7. We have y equals, again, I'm going to write this calculus friendly. So what does that mean? I'm going to write it as 2x to the negative 1. So instead of 2 over x, 2x to the negative 1. And then to take the derivative, you copy it to e to the exponent 2x to the negative 1 times the derivative of the exponent. That's the hook on. So once you understand the structure of it, I think the structure is pretty simple. Number 8. In number 8, you have f at x equals 2x squared e to the 3x. So because we have 2x squared e to the 3x, that second variable makes a product rule. It's not a constant in front. It's its own term. So it's a product of 2 algebraic terms. So the product rule is And so 2x squared e to the 3x. So the first 2x squared times the derivative of the second, e to the 3x with a hook of 3, plus the second, oh, I guess I have room here, plus the second times the derivative of the first. 2 times 2, subtract 1 to the exponent, and that's it. So recognize when there's a product rule and then apply that new rule to what you already know. And again, the exponential rules, I think, are pretty intuitive and basic. So that's good news. Number 9, that's going to be what rule to take the derivative. And if I had a monomial in the denominator, I'd think differently. But that is not a monomial. It's a binomial. So I am going to have to use the product rule. So what is the product rule? So let's see if we can remember it. So it's the bottom times the derivative of the top. So the derivative of e to the x is e to the x. It's awesome. Subtract the second, the top. So you want the bottom times the derivative of the top, subtract the top, times the derivative of the bottom, and then take the bottom and square it. There's the rule. Number 10. H at x equals e to the negative 2x, subtract 1 cubed. So let's look at this, and then take the derivative of this. This is the power rule with a chain on it, and there's actually 2 chains. So let's just follow it carefully. 3 times 1 in front is 3. That's e to the negative 2x, subtract 1. Subtract 1 to the exponent. Then, what's the derivative of the base? So that's e to the negative 2x. The derivative of negative 1 is 0. And then what's the derivative of the exponent? So it has like a little double hook to it. And then it's done. All right, that's the beginning of your assignment, 1 through 10. Mr. G Math over and out. I'm proud of you that you're doing your work. And then part 2 is coming up.